Let's move on to the next oral presentation entitled Tonko Macrophage, the application of binary CAR macrophage in SARS-CoV immunotherapy, presented by Ms. Huanxiao Shi.
Hello everyone, my name is Huanxiao Shi from Naval Medical University. The world has been affected by COVID-19 for 3 years. Omicron has been the dominant variant currently. Although the severity rate is low, the severe cases have increased worldwide due to the huge number of confirmed cases. Cytokine storms is an important characteristic of severe COVID-19. In the early stage, the SARS-CoV-2 suppressed inflammation, which favors its replication and results in cytokine storm in the late stage. Macrophages play a critical role in viral infection. Typically, macrophages can be divided into 2 types, the M1 type and M2 type, which are pro-inflammatory and anti-inflammatory respectively. In addition, accumulating studies have suggested that CAR macrophages exert a strong anti-tumor function in cancer treatment. So we wonder whether CAR macrophages can be applied in antiviral therapy. Based on the mechanism of cytokine storm, we think that promoting inflammation in the early stage and inhibiting the inflammation in the late stage may be an ideal way to prevent and treat severe COVID-19. The basic structure of CAR consists of 3 parts: the active domain, transmembrane, and endodomain. The active domain consists of scFv for antigen recognition, while the endodomain consists of signaling motifs for signal transduction. In our design, the active domain consists of scFv, which can specifically recognize the spike protein of SARS-CoV-2. The transmembrane domain is CD8 protein. The endodomain consists of 4 different signaling motifs. In previous study, Fc gamma, MEGF10, and CD3 zeta significantly induced the engulfment of CAR macrophages, and thus is included in our study. Importantly, MERTK is a tyrosine kinase, which belongs to TAM family. It can inhibit the type 1 interferon signaling pathway and thus may avoid cytokine storm. And these data suggested that MERTK may be a promising candidate for M2 type CAR. We then transfected THP1 cells with lentivirus vector and obtained 5 different CAR macrophages. Notably, we constructed CAR delta, which is lack of endodomain as the negative control, and we used the untransfected THP1 cells as the blank control. Then we could culture the pseudovariants with the phagocytes and applied intracellular staining on S protein in the phagocytes by flow cytometry. The results suggested that all CAR macrophages significantly engulf the SARS-CoV-2 pseudovariants. And then we test the supernatant from CAR macrophages, which are treated with variants by ELISA assay. The results show that CAR gamma cells increase the levels of interferon gamma, IL-6, 8, and TNF-alpha. Surprisingly, CAR MERTK cells did not upregulate the levels of these pro-inflammatory cytokines. However, doctors are difficult to judge the transition point of the cytokine storm. Therefore, we designed IL-6 sensors, which can a synthetic receptor which can regulate the phenotype change of total macrophage according to IL-6 levels. The IL-6 sensors consist 2 parts. The active domain consists of IL-6 receptor, while the endodomain consists of 2 different transcription factors, which are inhibitory and activating respectively. The CAR gamma gene is downstream of receptor 1, while CAR MERTK gene is downstream of receptor 2. When IL-6 levels are low, the sensors are not activated. The expression of CAR gamma is initiated, while the MERTK is silenced. And these effects promote the conversion of Togo macrophage into M-gamma, resulting in viral clearance and inflammation enhancement. When IL-6 levels are high, the IL-6 sensors are activated and the transcription factor are thus released. The expression of CAR gamma is silenced while the expression of CAR MERTK is initiated. And these effects promote the conversion of Togo macrophage from M gamma into MS, resulting in viral clearance and the inhibition of inflammation. In general, the oscillation of IL-6 levels and the phenotypic change of Togo macrophage act on each other, keeping the IL-6 levels within a safe range. To select the successfully transduced macrophage, we inserted various marker genes into the module genes and for the detection of flow cytometry. And the results suggested that all the module genes are successfully expressed in THP1 cells. And then to test the regulatory effect of IL-6 sensors, we added IL-6 into the system and examined the intensity of mCherry and GFP. We can see that when IL-6 levels is between 2.5 to 12.5, the Togo macrophage transforms from M-gamma into MS. And finally, we use mathematical model to guide the clinical use. According to the final formula, we used the cyclic algorithm and observed and obtained a curve where the IL-6 levels decreased over time and finally oscillated around a specific value. When the initial IL-6 serum concentration was 50 picogram per millimeter, the injection of 1,000 to 270,000 of macrophage can control the IL-6 tissue concentration under the level in asymptomatic and mild patients. And therefore, our models can guide the dosage of macrophage used in clinically. Thanks for watching. Well, thanks for question. I think the last experiment I mentioned in my slide, we tested the intensity of the mCherry and GFP and the phenotypic change according to the IL-6 levels. I think it partially answered the question that the sensitivity of the IL-6, whether it can regulate the phenotypic change. Mm-hmm. Yeah. Okay, well, so I think one alternative way is to modify the structure of our IL-6 sensors, because our sensor is it's work based on the the spatial structure of the two parts of our sensor, the distance of the GFP 130 and between IL-6 receptor. If the combination of the two part of IL-6 receptor is lowered, maybe the sensitivity can be modified.
Okay, thank you. I have my second question is from your very last slide, the result from your mathematical modeling. So the suggested concentration or number of cells is quite wide. So it's you suggest from 2,000 to 270,000, so it's quite wide. So do you have the way to make it a little bit narrower?
Yeah. I think it's a very good suggestion to make our injection more accurate. So the accuracy may be improved by modify our the formula we used in the future. I think. Thank you very much.
Thank you very much.
Any more questions?
Thank you so much.